we are going to answer this question before us. It says, a 5-sided dice showing the numbers 1 to 5 is thrown twice. By drawing a tree diagram, find the probability that at least one of the numbers thrown is odd and one is even. So find the probability that one of the numbers thrown is odd and one is even. Now, a question like this, you have to be really careful and you almost have to restrain yourself, because I imagine that many of us will be like, okay, I'm throwing a dice twice and I've got 1, 2, 3, 4, 5 options there. And then I need to throw it again. So off each of these, I'm going to have 5 options again. I mean, that's going to get real ugly real quick. So if we read the question again, is there a way that I could draw this nicer? Because we really don't want to do the first option. You shouldn't do the first option. Reading it through again, you can see that I'm only really concerned with odd and even, aren't I? So let's just draw an odd and even tree diagram. So I could either get an odd number or an even number. I could either get an odd number or an even number, an odd number or an even number. So odd or even, odd or even, odd or even. Let's see if I can draw that a bit nicer. There we go. Now we need to figure out what the probability of getting either an odd or even is. Now, I know that this 5-sided dice has the numbers 1, 2, 3, 4, or 5. Okay, so how many odds do I have? That's not an odd number. Whoa. Give me 1 second. How many odd numbers do I have? I have 1, I have 3, and I have 5. So that means 3 out of 5 of my options are odd. So I'm going to write 3 on 5 here, which means 2 on 5 are even. So there's a 3 on 5 chance I'll get an odd, 2 on 5 chance I'll get an even, 3 on 5 chance I'll get an odd, 2 on 5 chance I'll get an even. Perfect. Once we've done that, what I'm now going to do is list out what my sample space is. Sample space. So I can either get an odd odd, an odd even, an even odd, or an even even. Now, the question says, find the probability that one of the numbers is odd and one of them is even. So that means one is odd or one is even. I could either get an odd then an even or an even then an odd. So how can I figure out the probability of getting this one? Well, remember what you do here is you multiply across the branches. So odd, then even. So I go like that. So I'm going to go 3 on 5 times 2 on 5. And when I do that, I get 6 on 25. And then I'll do the other one here. So I'm going to go even, then odd, like that. So this will be 2 on 5 times 3 on 5, which is 6 on 25. So just to be clear what I've done here, remember to find the probability using a tree diagram, you multiply across the branches. That's what you're doing. And then to figure out this, the total probability of all of this, because we need to include both of these options, what we do next, and let me just partition this off just for neatness, I'm going to go 6 on 25 plus 6 on 25, which is going to give me my answer as 12 on 25. And that, everyone, is going to be my answer.